Hi, this is another aircraft electronic box. This one is a compass coupler from Bendix. This one was installed in a small aircraft. You can see the reference of this box. On the front there are 8 test points. On the rear there is a connector. The input of that device is a flux detector. This permits to slave a gyro using the flux detector. Normally we should have a second input, which is the synchro transmitter or the directional gyro. So there is also a sticker here. It is written that the compass card continuously rotates anti-clockwise. So it seems that this unit doesn't work properly. Okay, so first let's open this thing to see what is inside. Okay. So there are 2 electronic boards and an electromechanical assembly on the right here. Okay, so let's start with the boards. Okay, so this is the first board. This board is called the slaving amplifier. Okay, so we can see a transformer here. I think it is a transformer. And there are 2 relays. And there are 2 power transistors. There are also 2 transformers. One here and the second one here. And you can see that there is a strange part. This seems to be a power pump, but I'm not sure. Let's see the second board. Okay, so this second board is called Azimuth Amplifier and Monitor. And this board is quite simple. There are 2 power transistors here. And there is 1 relay. You can see the capacitors, this one and this one. They are attached to the board. And there is another IC here. This part is a CA30 something. I cannot see clearly here. I need a magnifier. CA3020. Okay, so let's see the mechanical assembly now. Okay, so there is a connector. I don't know if I can remove it from that side. Yes. Okay. Okay, the mechanical assembly is very simple. And this seems to be a simple servo control system. There is a motor here. You can see the small pinion. And there is a control transformer for the servo control. And there are 2 synchro transmitters, which are the output of that system. Okay, so you can see the motor control. So this is an AC motor with 4 wires. There is a reference winding and a command winding. Actually, it seems that we have 2 control transformers. Normally, the flux detector should be connected to the stator of one of these 2 control transformers. Okay, I will start to do the reverse engineering of that board. I have done the complete reverse engineering of that device. Actually, this system is identical to the Sperry system, which is here on the table. I have described in one of my previous videos. I will place a link somewhere on the screen. This electromechanism actually is the same than the electromechanism we have inside this indicator, except we don't have the pointer. But if you imagine that there is a pointer here, it is identical to this one. There are 2 outputs, which are these 2 synchro transmitters. And this device is expected to be connected to a heading indicator, like this one, for example. If you connect this electromechanism system to this indicator, you have exactly the same system than this one. This board is actually the servo control amplifier, which is something similar to this box here. This board is a sliding amplifier, which is similar to this box here. The block diagram is similar, so I will use the block diagram of that system to show you the difference. This is the block diagram of the Spirit system. We can see the master indicator in the middle here. This is identical to this electromechanical assembly. We have the two synchro transmitters for the outputs. We have the sliding amplifier, which is connected to one control transformer. This is this board. The output of this board is connected to the torque motor of the directional gyro. The output of the gyro is connected to a second control transformer. Okay, so we can see these two control transformers. One is connected to the flux detector, and the second one is connected to the gyro. And the output is this shaft here. This shaft is linked to the two synchro transmitters and the two control transformers, one for the flux detector and the second one for the gyro. And we have the servo amplifier, which is the second board, this one. This is the schematic diagram of the servo control amplifier. It is based on this power amplifier, which is this part here. Actually, this amplifier is the driver, and the transformer drives these two transistors. The output of this amplifier is connected to the motor, which is this device here. The reference winding of the motor is connected to an AC voltage with a capacitor in series in order to have a phase shift. And we can see that the input of this amplifier is connected to one control transformer. The stator of this control transformer is connected to the gyro. This is the schematic diagram of the sliding amplifier. The input is here. The input is connected to the control transformer, which is connected to the flux detector. So we can see, as usual, a capacitor. So this permits to tune the circuit to 800 Hz. So it uses the inductor of the rotor of the control transformer in order to have a resonance frequency close to 800 Hz. So there is a transformer, T1. This is this part here. Okay, so this part is faulty. Actually, the secondary side is open. So this is why this unit is defective. So actually, it was repairable. You just need to change this transformer. Otherwise, I think it should work. The output of the transformer is connected to an amplifier here. This amplifier is followed by a second order low pass filter. We can see here. There is a transformer. And after that, there is a demodulator at 800 Hz. So across this capacitor, there is a voltage which depends on the amplitude of the input voltage here at 800 Hz. And the voltage depends also on the phase between the voltage and the input here and the reference signal at 800 Hz. And this is a square signal. This JFET is used as a switch. After that, there is a modulator which permits to convert the DC voltage here into a 400 Hz AC voltage. This voltage is fed to another second order filter here, and there is another second order low pass filter here, and the output is fed to this transformer, which is the driver. And the driver drives these two power transistors, which are these two transistors here. Okay, and the output here is fed to the torque motor of the gyro. We can see here the circuit which permits to generate the reference signals at 400 Hz and 800 Hz. So this is very simple. The 400 Hz is generated using this transistor and one secondary of the transformer which is connected to these three pins, and the 800 Hz uses the signal which is on the common cathode of these two rectifying diodes. So the signal here is fed to this comparator which uses this inner diode. This inner diode permits to have a threshold which is somewhere here in order to have a duty cycle close to 50%, and at the output here there is a square wave at 800 Hz. There is another circuit here. This is another secondary of the driver transformer. this one here. When the system is left, the voltage is 0 here. So there is a detection of this voltage by this comparator here. And we can see that there is a relay connected to the collector of this transistor, and this relay is activated when the voltage here is below a given value. This relay is activated when this transistor is conductive. That is to say that this transistor Q10 is off. And this transistor is off when the voltage here is below a given limit. So this permits probably to detect if the system is left or not.